12A. For you, some time has passed since you saw this video, but for me, I just finished off Chem Chapter 12A Part 2 and Part 1. There hasn't been a time lag for me on this. So anyways, for us, we're looking at the second part of Chapter 12, and I do consider this important because you had to understand about solutions. But now we got to talk about concentration, because when you go on into other things, okay, concentration is going to play a main role, especially when we're starting to talk about acids and bases. Okay, so let's go with it. Our objectives today: student will be able to define the concentration. Okay, we're not talking about, oh, I gotta go take that quiz. Yeah, gotta concentrate. It's one version of concentration, but in chemistry it's a very different thing. Okay? You will be able to perform calculations using different concentrations of solutions to find the mass or moles of solute. Oh, moles. No, not the moles, Canu. That's why notice I jumped a few chapters ahead to get to solutions, because moles are still freshly in your mind. Remember, boys and girls, a mole is a number. Yeah. Okay. So that's our two main objectives, okay, for today. It's very few slides because this is actually going to be in two parts. One part I'm going over the concepts with you guys. The second part we're going to be doing some problem solving activities with this. Okay? So, as they say, let's get this party started. So how do we define concentration? Okay, now some people would use the word concentrated, like orange juice concentrate, or we can use the term diluted, okay, not he is so diluted as to his abilities to play soccer. Not that kind of diluted. This is dilute. In other words, the concentration is less. You've watered it down. Okay? So dilute and concentrated are not precise terms. We need something that's going to be more precise, especially if we're talking about acids and bases. Okay? So concentration is a measure of the number of solute particles in a certain volume or mass of the solvent or of the solution itself. So in other words, when you look at concentration, think how much solute is mixed in with the solvent. It doesn't matter if the solvent is a liquid, a gas, or a solid. This is all about concentration. You remember talking about wedding rings? You know, the gold rings, the carat? The carat, that 14 carat, that is actually a unit of concentration for jewelry, okay? For gold. That would be kind of an important thing. Because having a 28 carat, you know, gold ring, I have to be very careful because it will break very easily. 14 carat is pretty standard. 10 carat is like you can find that in places, I guess, like Walmart or something. And it's like, why bother? At that point, find another metal. Because the yellow and the gold is just not there. Okay? But that's the concentration. It's a measure of the number of solute particles in a certain volume or mass of the solvent or of the solution itself. So concentration. So the basic idea is this: how much solute over the solution or solvent that you have. So it's a very simple formula. In fact, this is it right here. Okay? But there are types of concentrations that they do use in chemistry. There is percent by volume. Wait, where have you seen percent by volume before? Oh yeah! The rubbing alcohol bottles. You notice they got like 70%, 80%, 90%, right? And vinegar, 5% acidity. That is a concentration of percent by volume. Okay? So when you look at vinegar, all right, it's 5% acidity, which means 95% of what's in the bottle is water and 5% is actual acetic acid, which is normally known as vinegar. When you look at hydrogen peroxide, 3%, 97% is water, 3% is the actual H2O2, hydrogen peroxide. Of course, wait. So you're telling us, Canu, that when we go buy a bottle of this stuff, we're really paying for mostly water? Yes. Yes, you are. Oh, that's a ripoff, man. I want my money back. Come on. You want the truth? You can't handle the truth. If you had pure H2O2, pure hydrogen peroxide, it will put a hole in you. That stuff is nasty. Personally, I've worked with 30% for an AP Biolab. Man, you think I'm white? When the peroxide dropped on my skin, it made it even whiter. No, man, I don't like working with that stuff. So that's percent by volume. Percent by mass, okay. Molarity, that's the one we're really going to work with here, guys. There's also molality and normality. So these are like the different units they are. But pretty much we're going to work, most people see percent by volume. That's what most people see in their everyday lives. Molarity, we tend to use that more in chemistry, okay? There is also other concentrations like parts per billion, parts per million, and I might talk about that later on, depending. Okay? So molarity is moles of solute compared to the volume of the solution. So for example, 6MHCl solution, that's a 6 molar hydrochloric acid solution. You pour that on your skin and it's gonna hurt. It's going to leave a mark. So how do we calculate the molarity? Well, we calculate it by the moles of solute per liter of solution. It could be more than 1 liter or less than 1 liter, doesn't matter. It could be more or less than 1 mole of solute. It's pretty straightforward in that regards. Okay? And we have come to the end of Chapter 12B. Well, you got to admit, Chapter 12A was like in 2 parts, and it was really long. Chapter 12B is really short, but what I'm going to do, I'm going to make another video, like right now, and you guys will catch that a little bit later. All right, guys, I will catch you on the flip side.